Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 3 for this week. And we're going to be talking about this little bit of a paradox in the sense that on the 20th of June, yesterday, the sun was as high in the sky as it's going to get for the entire year. Its rays are most direct. The day is the longest of the entire year. And yet, on average, if you look at a 30-year period, the hottest weather of the summer doesn't usually occur until about 4 weeks after that. And it's similar to what happens on a daily basis, that the sun may be highest in the sky at noon, or actually this time of year because of daylight saving time around 1, but when does the high temperature occur? Later than that, usually about 4 or 5 o'clock this time of year. So it's the same principle, it's just applied to a shorter time scale. So why is this? Well, let's go on ahead and take a look at this in a little bit more detail. And this is a graph of the length of the day versus the average temperature over a 30-year period, or the normals, if you will. Now, there are two scales here. On the left, you're taking a look at the number of hours of daylight, okay? And that corresponds to this blue line here, okay? And then the orange line, or tan line, or whatever you want to call it, corresponds to this scale here, which is the average temperature, okay? And so I set it up so that the two basically look similar, they're just sort of displaced, okay? So if we take a look at the peak of the amount of daylight, that is the summer solstice on or about June 20th. Well, not on or about, exactly June 20th this year. But the average temperature, based on the period from 1991 to 2020, it actually peaks on July 16th. Actually, July 16th and July 17th both have the same average temperature. So there's about a 26 degree or 26 day offset there between the peak temperature and the amount of daylight. So again, why is this going on? Well, let's just take a look at a box here. Actually, the analogy that I was taught with is a bathtub, but I am nowhere near the artist capable of drawing a bathtub. And so I just made a box here, okay? And the blue is the water level in the box. And I'm going to allow that to represent the average temperature, okay, of the air where we live, okay? Now, on June 20th, we have the sun and we have the earth, okay? Now, there is a certain amount of radiation coming in from the sun, okay? And then there's outgoing radiation from the earth that goes out to space, okay? But on June 20th, there is more coming in than there is going out. And so as a result of that, we continue to warm up. And even though that arrow here, representing the incoming radiation of the sun, this arrow begins to gradually get smaller after June 20th, it is still bigger than the outgoing radiation from the earth until we get to July 16th, okay? So at that point, the arrows are exactly the same length, okay? The water level has gone up, representing warming temperatures, but at this point, we reached the equilibrium, okay, where there's as much coming in as there is going out. And then, arbitrarily, let's move on ahead to August 16th, and by that time, the incoming radiation from the sun is less than the outgoing radiation from the earth, and so temperatures start to cool down, okay? In fact, July 16th is the point where the equilibrium is reached, and then after that, it starts to go down, and the water level, which represents the temperature of the air, is going down as well. Now, you may ask yourself, well, Greg, I remember some awfully, awfully hot days in August and September, and in a few rare cases, even October. And you're absolutely right, okay? So in the summertime, just like we have in the wintertime, you have weather systems that are moving along, and they displace these air masses either north or south. So in the wintertime, you may get a big storm that goes up to your west, and it sucks a lot of warm air from the deep south all the way up into North Carolina, and you end up getting unseasonably warm. And even in the case of the summer, as you head into August and September and early October, even though that radiation balance is beginning to shift, you still are going to have situations where a warm air mass is going to be sucked northward or a cold air mass is going to be driven southward. And so you can continue to get very, very hot temperatures even into the months of August, September, and even October because of these weather systems that are displacing air masses. But when you average the whole thing out over a 30-year period, it turns out that July 16th, at least for the Triangle area, is the hottest day of the year. But again, that doesn't mean that on any individual year it's going to be the hottest day. That can still occur later than that. It can occur earlier than that. It just all depends on how the weather systems happen to move along in that particular season. So bottom line is that the sun's radiation, the reason there's this offset is that even on the longest day of the year and the day when we have the most direct radiation from the sun, that there is still more coming in than there is going out. And so that's why things continue to warm up, and we have to wait for that equilibrium level to be reached, which is on or about July 16th. And then after that, there's more going out than there is coming in, and as a result, temperatures begin to cool on average. But again, it does not mean that you can't have some very hot days in later July, August, September, and in a few rare cases, October. All right, that is the weather video, bonus weather video number 3 for this week. Hope that made a little bit of sense. I hope you have a wonderful Friday evening and an even better weekend, and we will talk to you again on Monday. Take care, everybody.